Welcome back to Cloud Computing and Big Data. Today we have our practical lecture 5.1, Understanding MapReduce in Cloud Applications. And this is the second part. While in the first part we reviewed a little bit, again, MapReduce, we understand that basically map and reduce has some interesting third phase in the middle, which was the sorting, shuffling, and grouping by keys. And this is a powerful mechanism and something which you can really basically leverage from these frameworks like Hadoop and Spark in order to have very interesting applications, which in the end fall back to very simple map and maybe very simple reduce operations, but you do them at scale on the big cluster. And of course, here the idea of the data locality comes in, if you remember from one of the earlier conceptual lectures, where you said, here we want to achieve to bring the computing to the data, right? So a simple task to the data instead of transferring, let's say, petabytes of data towards a big computing engine, which in one way or another is probably best done by just putting a couple of hard disks then in a car and then drive to the computing center and basically unload them, because transferring petabytes from, let's say, simple users up to a computing center can be quite some tedious task. Hence, here the idea is a little bit the other way around, which was also motivating this big data analytics frameworks. Basically, the data is usually accumulated in, big players like Facebook, for example, or YouTube, and then you want to basically rather on their storages work on smaller computes. Hence, the map and reduce task should be also not computational demanding, very much like in high performance computing. Of course, there you have an order of magnitudes and basically also a very interconnected way of doing parallelization. You have not an embarrassingly parallel or nicely parallel part that we discussed in the first part. There, of course, in HPC, you rather have lots of communication between the tasks, which you don't have here in the idea of MapReduce. Here, you really, basically have a high throughput computing problem. We then basically explored that using MS Azure with Jupyter notebooks would enable us very quickly in PySpark to create a session, and from there, with a one-liner almost, get a MapReduce operation done. And of course, this is directly scalable. So you basically could have terabytes of data. And by having enough workers, we would be able to really digest this data very quickly, much more quicker than you could do on your laptop, if it would be possible at all. We then continued and see basically that in all different cloud vendors, we have some form of this open, let's say, open Apache stacks, as we call them, big data analytics stacks available. This is in Google the case. We have it also in MS Azure scene. And the first part looked a little bit into AWS and understand, of course, before we even go in the Elastic MapReduce service, which is basically the idea, very similar like we have seen in MS Azure HD Insight, we have to do some preparatory work, and that was basically having our keys. So here we connect now to the first part. So we have created some keys, and this was necessary. I just have a look in this again here for you to connect better to the first part. You see, we were in this Amazon, we are basically under the regime of the EC2 of this elastic computing part, though the virtual service. But what is also very important is basically that we have picked a specific region, which could be US, could be Asia, Europe, etc. So that is something which is important because the keys usually are basically done for certain regions. And you have to make sure that when we create now the EMR cluster in the second part here, that we also basically want to do this in the Ohio space. And of course, you can switch the spaces here. You can go to different parts. The costs of the resources here and there switch. The availability of the resources also switch. So this is something where we here in Ohio have just done the demo and we know that it works. It's why we stick to it. But here and there, you should, of course, normally in a production setup, consider maybe going more to Europe, as you see here, basically in several locations. However, for us now as a teaching demo, it's not so relevant. Much more relevant is, again, to understand the approach to clouds. Let's say when we want to do now the simple word count application in Spark, as we have actually discussed a lot in the first part, although it's a very simple service, we want to do that at scale using Apache Spark or Apache Hadoop, and to prepare ourselves maybe for a production setup where you would have then basically maybe petabytes of data coming in basically in a stream or basically through a big pile of documents that you want to look at. really by actually having a scalability inherently by not basically programming for it. And this is something what the framework gives you. Now, what we learned already in one of the earlier lectures is this kind of recipe, if you want, a kind of stepwise approach, which is always a little bit similar, right? That is the idea that you learn that you basically get out of this course by having these kind of stepwise approach a little bit in your mind. Obviously, here and there, we have to do some small adjustments. You see here, we are not interested anymore, obviously, in the subscription to MS Azure. When we go to AWS, it has no relevance there, right? So, of course, the cloud vendors can be used in parallel. But of course, the accounts, the subscription, everything is, let's say, disconnected. So here we're interested now as a first step, thinking about a subscription in AWS, and that's what you already know. We have basically now the pay-per-use of resources. What we then want to do is basically having a Spark cluster in AWS Elastic MapReduce, which brings us then this computing infrastructure, right? So this basically, the framework should be installed. I don't want to do that my own. Don't want to install Hadoop, don't want to install Spark. I want to have a way of creating this, and then it's all installed for me. And then, of course, I can start up the Jupyter Notebook to use Apache Spark. I will demonstrate this very quickly, but then we also want to explore here in Amazon something called streaming and for Wordcount, just as another, let's say, example how you can do it. It needs not to be always a Jupyter Notebook, because there you're very manual. And of course, with the streaming, you could automate a bit more the process. I will show you in a moment. Also interesting for us is here to use one of the most, let's say, used cloud service probably that is existing. You would see the AWS S3 service a little bit, and the idea of buckets and basically what the service is about. And of course, then using that in conjunction with a Spark cluster by doing maybe just an application like Wordcount with the MapReduce steps, and then perform this automated word count on a cluster and get the results. Don't forget to terminate the cluster in the end, as you know, because otherwise it will create costs. Also here, I would like to highlight a little bit the functionality of Amazon, for instance, where you have this auto termination, which actually comes in handy because, as you know, even if the cluster is running, you don't use it. I repeat myself, but it's very important to understand that concept. Again, when the cluster is running and you're not using it, you have to pay. And with an auto termination, of course, here basically the cluster realizes I'm not used, let's say, for an hour, so let's terminate myself to save costs, which could be really a big difference, right? When you think about running this running these services 24 hours, 7 days a week. So let's implement the steps with AWS. Obviously, we start with the management console. We have to log in. We have to get our subscription here. I basically connect to the first part where we said, okay, unfortunately, EMR as a service is not really anymore in Educate, something what universities, I think, don't really like, including myself. There's some discussion threads also on the internet. It's a bit sad. In 2020, we could have done this, but not anymore. Also, the academy seems to be much more oriented towards industry and getting certifications, and so it's not so easy to just integrate this in lectures. Otherwise, we would now teach maybe for the next basically 5, 6, or even until the end of the course, just Amazon. And that's not what we want to do. We're not paid by Amazon. Basically, in the end, also, we want to give you some overview what other services exist, not only Amazon services. Unfortunately, EMR is also not part of the free tier, so we have to go the pay-per-use way, as I said to you earlier. Now, how it works is basically very similar in the way how we did this in the MS Azure space. So let's do this practically again here. We have all services. We already said the EMR is somewhere here. Elastic MapReduce. And we remember, we have this kind of keys created that we can do later on. And when we now create a cluster, basically you see I had already created a couple of them here to test if it's really work. So here we basically can now create a cluster where we directly go to the advanced options, something what I would recommend to have a better control, better overview what is happening. So many of the things I will tell now are basically also in the slides, right? You see here software configurations. This is the first step. This means EMR in specific versions. And I think this is one of the unique selling propositions of Amazon. You see here quite a lot of different stacks and different versions which are supported. And the point is that every time you switch to different releases here, you also switch in the underlying related tools that you see that actually work with this particular version of EMR. You see here 6.7, for instance, uses a very recent version of Spark, while the AMR5 using a Spark 2.4.8. Also, this is an interesting thing because you basically can switch and organize, right? While here in the not advanced options, you have a very small view on this. That's why I recommend to do always the basically the kind of advanced option version, because there you have a much better overview what really you install, what packages are there in which versions, which could be a crucial thing. So this means these versions have to be in line with each other. So when we do now here what we have in the slides, basically when picking different specific versions, you will see we can go quite back in history and see basically how that was supported and see it's still Hadoop 2.10. For instance, we maybe want to have Jupyter, of course, to connect to the service. Then we have Hive, etc., 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 etc. When we see of basically going then over time, you know, basically you see now this is an old EMR 5 3.1. Maybe we're interested in, let's say, a new EMR 6. Things change. So basically, we will see Hadoop from 2. Hadoop, Apache Hadoop, I mean here by this, the stack changes. For Jupyter Hub, we have suddenly also something called the Jupyter Enterprise Gateway that you need in order to connect better to the Jupyter world. Spark is in a different version, as I said. Pick for scripting and so on, we keep here, not so important. Hive can be used here for table metadata. That is quite useful for some applications, also not so relevant today. And basically here's already what we will use later. We can basically do certain computing steps automatically. And that's where basically the streaming word count comes in later. But in the moment, we're just interested in creating this cluster on our own in order to, let's say, create the infrastructure in a way as we did it with MS Azure, right? So this was quite interesting. We had a Jupyter on a cluster available. So what is the next steps? Basically, you have to define the resources. This is something what you already know, right, from the MS Azure part. Of course, now the price parts are different because we're now in the AWS space, but the general principle of saying the more, let's say, powerful CPU or virtualized CPU, I should say, you need or want to buy, the more you pay. Right, you see that a little bit nicely also here on my slides, basically alluding to some of the prices. I think here is a copy paste error. Let's correct that here on the fly. So we have an M, X large, and you see that. I think that was the update from the price this year. But in the end, the idea of taking these resources together and then basically create, of course, multiple instances. We have learned the master is always needed. Here, the question would be if one instance would be really good. You have seen, based on one of the early examples, maybe having a secondary master would be a good idea. Because if the master is down, nothing works anymore, right? So even if you have, let's say, different workers that you basically have here, and they all, let's say, are 20 instances and they all can work nicely. If the master is not managing all of that, as we have seen basically with the name node and metadata idea in the MapReduce, then basically you have a big chunk of data everywhere. But the essentially point is nobody knows where all of these chunks of data are. So in a production setting, you maybe want to have the master also as a secondary part. We leave this now basically here as part of this because it's not directly adding insights in terms of teaching. You can also configure automatic cluster scaling, which is of course very nice if you think about your workloads, that you basically can adjust the numbers of this kind of cluster given your usage. So basically sometimes you maybe have a big team working on it daily, and then suddenly there comes a vacation period where just one guy is left in the team or lady left in the team that basically wants to basically use a cluster. And then you have a very different load scenario. Here you think about, changing maybe the number of workers and things like that, which is quite nice. And another thing I wanted to highlight here is, of course, is auto-termination. As you know, in the last couple of lectures, I was really giving you, hopefully, a very good briefing to be careful of costs in clouds, especially if you now potter off after that course and create your startup and want to use cloud resources. If you do it yourself, please always remember me when I say terminate services. This could be the end of your startup very quickly, because this will burn resources. And this auto termination that you see here for the EMR cluster is beautiful. Make sure you have these enabled. And also, if you go to the MS Azure space or Google, they have similar ideas, or at least monitor basically the use of the resources that can quickly accumulate more than you think. Right, so but with this, I think you get the story that in a way, the overall modus operandi, if you want, is very similar. Like we have created MS Azure and the HD Insight service. Now we have this a little bit as a different look and feel, different prices, of course, but in the end, you have a very similar setup. You can configure a little bit the logging, how the cluster is named. Maybe we call it the CC Big Data 22 EMR cluster. Morris. And then you basically are almost done. There's just one thing left, which is now important. You connect this to your key that we created, right? And here you have a couple of keys. I think the one we just basically developed here was the Morris CPD course new, but it really doesn't matter. Important is more that these are then also for Ohio, where you create basically your service, right? And this is then basically something which alludes also to security configurations later. It's your idea of how you can use perhaps other login mechanisms to your EMR cluster. So you have a key pair now that not only can be, so to speak, looking into the pure EC2, but also to the EMR cluster, which enables you maybe then also doing MapReduce in a different style than you just see here. So we're creating this cluster, which, as you already also know from HD Insight in MS Azure, will actually take some time. Hence, you see here the cluster is starting, it's provisioning the master, it's provisioning different workers. And with this, we basically have to wait, as it is, very common, before we do anything with Jupyter notebooks, before we do anything. So let's proceed a little bit with the slides, basically to go forward in this and to stay in sync. So we have basically talked about the prices. I think that's very clear, which basically should be something you always review. Again, I mean, the ones that you see here, perhaps not the best ones for a Spark cluster. You know that by now, but as you also know in teaching, we cannot afford to always have the very big gigabytes here used for our teaching budget. In the end, that is something where basically then real production companies will probably pick a very different setup in terms of which ones of these instances they will pick. Maybe some of them which have much more gigabytes and more cores available. But in the end, we have also seen it's very similar to the idea how we deploy essentially this in HD Insight. Now we basically in the AWS space, which is also quite nice and connects to different other AWS services we will now have a look in. The important part was connected to the right key pair basically in Ohio here, because you also have the service to create it in Ohio. So all of that needs to match when you want to have a proper setup. And again, as the idea with the key is, you can use that now with your own SSH client. You can log into the cluster. You can basically then use the cluster in different ways, and actually also configuring it from the security perspective in different ways. But this is your way how you control and access it. And another alternative mechanism basically to log in, because now, as you see it here in my demonstration, we are basically logged in, of course, at the AWS Management Console. So this is another way how you control it, because you are already authenticated, authorized to do this over this mechanism, and the SSH keys allow you now a different way of basically doing this. Remember, never share the private key, obviously, with someone else. right? Again, very important, the private key never should leave your laptop, right? That's just for you. The whole principle is that you can distribute freely the public key, but you have the only matching private key. So as long as you keep it on your own laptop. And this enables you then proper authorization mechanisms to log in remotely into different cloud services. And EC2 is just one example. There are, of course, other examples. And EMR is now something which is, so to speak, on top, basically, of this of the EC2, which is then also using this. So then from deploying, once we have all done these configurations, we see now nicely we have specific applications that actually work together in specific versions. And this is one of the unique selling propositions, perhaps, if you really want to have a Spark cluster compared to your own, let's say, in-house, or as we say, on-premise cluster. Because when you do this, alone, the different versions that you have seen when we're creating this, so achieving the backwards compatibility is tough. Also, keeping the cluster up to date is relatively tough to all the different versions and all the different flavors of services. They need to work together with the different Python versions, but also with different Java versions and different Spark versions, work together with specific Hive versions. So long story short, you have quite a very complex setup, and don't underestimate this. Even if you think it costs quite a lot, it also would cost quite a lot to have an administrator hired in the company that actually has to take care of these applications, because they move, they're open source tools, right? As you have seen from my, browsing through the different versions, you have seen Spark 1, Spark 2, now Spark 3, and of course the world will go on. In Spark 1 times, we didn't have Jupyter. Now suddenly Jupyter notebooks, very nice. Suddenly you have Jupyter Labs and Jupyter Hubs, so a better way of sharing with different peers, with a much better scenario of working with Jupyter. So all of this is evolution of these services. And when you want to achieve that in your own company on premise, it can be done, but it just also needs perhaps one person just keeping track, installing, and doing that. Hence, administrators are very well needed. Here, the beauty is, of course, the administrator is paid by Amazon doing that all, and then having, of course, economics of scale that many users then, of course, use these different versions. But let us look now a little bit if the cloud actually comes along. So here it makes sense to refresh every now and then and see if we have some cluster now. And we see already some improvements, some bootstrapping. That usually means several configurations takes place. It's not only just resource provisioning. Here, the master is kind of installed. It's basically configured now for this MapReduce cluster that we have asked for. And this is also, let's say, a small progress here and there. I think this interface is also nice to get feedback. So you will see we get different steps in computing. You see different Hadoops, Hadoop debugging options are actually created, and you can see quite some, metadata, what's happening, so that you have also control and see if there's some errors and so on along the way. You have control of the hardware. You can monitoring the usage. Obviously, we're just basically deploying, so there's not much, but this is a quite nice way of doing it. When I think about also other services, you have quite a nice overview here in the EMR space. So let's go a bit further, because this, as I said also in the slide, may even take 10 minutes. Hence, we want to go ahead a little bit. Similar like you would basically do once this cluster is basically up. You would then create a notebook later on, and I will demonstrate this, of course, as soon as the cluster is ready. But you see it essentially already on the slides. Once you have a cluster, as this Amazon EMR created, so this would be something like this, that you see master and core is running. Before you don't have them both running, don't use Jupyter. Obviously, Jupyter depends on the cluster. So that means really this cluster, however it is called, needs to be waiting and cluster ready. So ready for basically this notebook. Here in AMR, you basically create a notebook and then connect it essentially to an existing cluster. It's a bit the other way around we have seen in MS Azure, right? Where we picked a cluster and then basically had Jupyter Notebook on that one. So here you have it a little bit the other way around, but it doesn't matter to us. More important is that this cluster is really running. Once there's an error with the cluster or not really ready, it will not work. Although you may be able to start Jupyter, it will not function properly. Once you do this, you can open it in, Jupyter Lab. Essentially, then you have different ways. This is an example here where you then create different notebooks. PySpark already, the kernel that you can use from our work before, but also Python 3. Interesting enough, you can also SSH directly in the terminal. There are different ways how you can then interact essentially and work with Jupyter. Obviously, for us, that means now we could go into a new notebook, we can create a new PySpark notebook and could reproduce the word count that we have seen in the first part of the lecture in MS Azure, right? So essentially, we can just take the same copy and paste the text and Python code that we have seen in MS Azure and now basically execute it on AWS. Of course, here and there, we have to think about the input file, which was basically then this food inspection of Chicago, which is in another, let's say, part of another cloud. So there's obviously the input data and so on. You have to justify a little bit and adjust to the right setup. But essentially what I'm saying is you can just use that. But let's see, in the light that we still wait a little bit on our cluster here, we also can basically go a little bit further to save time, basically to think about already another service I wanted to show you also in practice a little bit today, which we then connect with Wordcount basically after it. And this is this bucket store. We have talked about it briefly before, that basically you have this bucket idea that you throw in data. All you know is basically key value, basically a bit of metadata and so on, and who can access these data. So, and this is a very simple store, hence it is actually also the name of the service. And it's by far one of the most used ones in clouds, I would say, from the storage perspective. Even I was alluding to Gradescope, for instance, that was using S3. We had seen Spotify, Airbnb. They all use that service in one way or another. And of course, it's virtualized storage. So in the end, you have really physical storage somewhere. But it's a very nice interface to use it, a very simple interface, also that you can use with so-called web services like representational state transfer or simple object access protocol to see here. But the key point is really it's very simple. You put data in and don't really care about the sizes because it's scalable. So of course it should be growing in size with the cloud. And of course, here you go, right? You pay for it, obviously. But of course, what you get for the money, so to speak, is also kind of 99.9 durability. So that's a very nice number. And obviously you can replicate the data. It's very secure in a way. So basically it's, of course, in the cloud. So still there are some security risks. Still the way how the clouds usually set up are basically still relatively safe. So when you do this, we want to do this a little bit now for preparing our later parts. So let's go here and open this in a new tab while we're still waiting a little bit on the cluster setup, which is completely normal that this takes quite some time. And in fact, you see already the master is now running, the core is running still. There needs to be still some configuration in the cluster software. So we better wait a little bit here. Instead, we can go to actually the management console. And as we did with EMR and EC2, we want to have a look in our bucket store. S3, the interface of that is a little bit changing over time, but still the same idea is that you create these buckets. Here's one that I already created, for instance, and some of them are automatically created for log files, what's happening. But here you have this interesting store, Rich, that we will also discuss more in depth actually in following lectures. So this lecture cannot go in all the details of this S3, but take away the message that we can create now essentially a space in the cloud where you can put some data. And for us, that means notebooks. As you already see, there will be some notebooks here what we already created in the cloud. So basically something needs to be stored there, right? It cannot be flying in the air. So the notebooks we basically will use in this environment have to be stored also in S3, just as an example. And then of course also some word count output would be quite nice to have. So here you see essentially kind of this word count output that we have and that we want to maybe reproduce here. So you can simply create a folder and you would say word count example again, example, and then have already a space in the cloud that you can now basically connect to. And we will reuse this kind of part later when we want to have the outputs basically of this Apache Spark, Apache Hadoop streaming of the cluster. So that's quite nice. And let's see a little bit that this here is now coming up to speed. We see basically that's good news. The cluster is waiting and it's ready. All the steps are completed, running. It's the master here and the core. If you want, we also can look on some of these data here. Basically, this has been completed, the Hadoop setup and things like that. So that's very nice. As I said, also here now suddenly the notebooks appear, which is important for us. And basically, you see, I created another notebook before, but let's create another one where we see CCBD notebook new. The names don't matter so much, but this is important. As I said to you, we have to choose a cluster that is really waiting and which is cluster ready. Otherwise, we have lots of trouble. We choose this cluster. Here we can configure some other parts that we want to use here, default locations and so on. And there you go, you create a notebook. And with this, once you have created it, which is also a little bit different, like look and feel from MS Azure, right? Here we also create now a notebook. On the other one, we really basically were directly executing a Jupyter notebook on this cluster. So here you have a bit more management interface around this. You can basically easier download and move these different kind of resources. So that's quite interesting. Also, let's go a little bit, however, with the idea that we also wanted to have now another cluster, perhaps where we do this automation step. And this brings us back shortly to the slides, where we basically created now the bucket. And now what we can do is basically using the so-called basically an idea of how you have an implementation of a certain MapReduce already given as part basically of some source code that you want to reuse. Here in an example, we use the word count that is already integrated essentially inside basically the examples in an S3 store that we can access, which is important for us when we want to configure the streaming program. So hence, when we do now the idea of creating this, we need a new cluster. What you see here, we do again the software configuration and things like that, and we'll basically also connect it then to our point. So basically we have to go back to our EMR. Although the other cluster is now happily running, we create a new cluster where we said this is a cluster for, let's say, CCBD streaming. Example. And of course, as I said to you earlier, go to the advanced options is important. Basically, we will take here, I think, again, the latest, greatest version, although that doesn't matter so much, but we can also take the 5.31 to be in sync with the slides a little bit. But here I wanted to show not this functionality here on top so much. Of course, we have to click on Spark. We want to use this functionality a little bit. Hive. Of course, we can do Jupyter Hub in case we need it for some other parts, use metadata. But what I really wanted to show you is basically now think about these steps, right? So you basically say you have a streaming program, and you see there are different ways how you can now configure these steps. Your own jar, this is a Java application, or the streaming program that we basically now reuse. And you have the information here on the slides where essentially the map application is already implemented as a Python, basically here and prepared that we can easily reuse. Then we have a reducer operation, which we basically have later, which we basically can have as a aggregated version. Then the input data set is obviously very important. Also there we have a predefined input location. And for us now important is a bit the output. As I said to you, I created a bucket store for this, the S3s, and now you see how nicely that is connected. You have EMR services, but what you do now is connecting it to this word count example bucket store. And here's important also that you maybe select this one, but then you have to add your own new bucket parts. So it's class demo, also where the results will be in. And you add this and basically have here a jar that is now this kind of idea of using MapReduce much more in this kind of streaming fashion with this pre-installed part. The same story goes, however, with the resources you can add, remove. So also here, my cluster name is of course something you can change to CCBD streaming cluster, and then next. And of course also connect to the one from the have on Ohio here. So do it a bit quicker because it's the same, obviously, what we did before. Now, the only difference is that we are now more interested in 2 steps. So here we have a streaming program. So we're not just creating the cluster. We also create some different steps on the cluster before. And this could be very useful for automation. There are different steps that you can do. It's not just one step. So you can have a whole chain or workflow if you want from all of this in order to really, when the cluster is ready to be started. In our case, we want to do a little bit of word count. And while we're here, basically in the old cluster, if you remember now, just maybe want to open the Jupyter lab, just to show you that, of course, the idea here would be now to create maybe a PySpark kernel, and then use the same code that you would have in MS Azure, essentially just have to adjust, as I said, the input data. This is all possible, nicely integrated as well. We don't go into this today because essentially of the time, we just have 40 minutes per lecture, but you have here an overview of the different parts of Jupyter Lab that you can then use. And the PySpark kernel, Python 3, the Terminate to go SSH in 2, and so forth. But here the look and feel is very similar, like we had in MS Azure, so also the learning experience would be not so much. However, we're looking basically onto our streaming server now. So what is happening here? Obviously, this also takes a bit of time. We see the same steps, provisioning, etc., etc. So also here we refer a little bit to the slides, basically where all of that is presented, where you basically have this new folder for specific results that you get from the framework. And then what's happening is that once the cluster is running, you basically can see then that this MapReduce function is performed on the cluster. It will basically have this implementation of the mapper function with the word splitter. In the end, you have something which splits the words and then aggregate the number of occurrences, which essentially is here the kind of +1 every time you find the word. And then, of course, the aggregation means we will add basically and aggregate to each key and have in the cloud then in the end the word count results. You see here an old run in Virginia, of course. When you now go to our example here, we will go maybe quickly. I think we can close this Jupyter Lab here, but essentially can quickly, before we close today, show shortly in S3 how that really looks like, while our cluster maybe takes a little bit more time to go up and basically be ready. We can just here look. Basically, this is still in the bootstrapping and starting phase. We can already look on an old run that I have performed just for you to show. Our new one is here in the word count example, but what I did before was a word count output example basically before. And what you see is really the parallel part now, that basically all of these different parts have essentially now been created by this word count applications. And if you look into this and open these, basically you can directly see that essentially, and you have to basically download this properly and so on to look into this. But I did this basically here on the slides, and you see a little bit how this looked like when you go into this, that nothing else is there than just our results that we would expect with having all the words counted. And the parts here suggest, of course, that this was done in parallel by different workers. That's also very important to understand. It's hence the point comes with a parallelization. And then, of course, also the success flag is a good indicator to just say, okay, Hadoop was actually working fine. There were no errors. So all of this, what we had here in the streaming, was actually working. And here I put you a little bit how that looks like in one file. The different, let's say, words that we found. Obviously, in this example input, we have a bit bolder text, not only this kind of README for the city food inspection that we had earlier, but the same story goes. It's scalable. We can do this with petabytes of, library data, and this would be all scaling well. Obviously, you need to have maybe a couple of more workers and a better, let's say, stronger core with more memory if you really want to leverage it. Just to connect to some things we have used inherently, the Yarn, as you basically know already very well, is basically driving a lot. This is scheduling of the cluster, so where basically the workers then execute the different tasks basically for doing this map and reduce. And also the Spark context we have used basically in the first part of the lecture, also here would be used in order to basically manage the whole execution. Also here, think about now that this was just stretching the surface. We could go on and do Mahout on this cluster. We could go on and basically do more Hive SQL like you have already done a little bit in HD Insight. And you see here, known open source analytics frameworks are basically everywhere. And with this lecture is really introducing you to a very powerful tool, but we had merely time to really go into details of many others that are existing. Maybe a final check if the cluster was already, let's say, working, still in the starting phase, but it doesn't matter. I think we will see essentially the same output we have seen already here with the different parts in the word count output. That's what it looks like. So I think it's time to close this lecture. And with this, I thank you for your attention, and we will see us next time with lecture 6.